Hello, welcome to this session about transferring files with HTTPClient for this Elevate 2024. We're first going to go through an overview of what the session is going to be about. We're then going to go through a brief introduction on what the HTTPClient object is. Then we're going to go through the section about uploading files to an HTTP server. Then a section about downloading files with the HTTPClient object. And finally, we're going to be showing how to upload files to a cloud service provider. In this case, we're going to be working with Azure. In these last three sections, we're going to be going through the steps first, the theory and the explanation of what the context is. And then we're going to be showing a practical demonstration on what is necessary to do. A little bit of context about myself. My name is Francisco Martinez. I'm the main developer of the Power Builder Components app demo and the Power Builder DW2doc demo as well. My main focuses are C# development, mainly on application development and web API development as well. And lately, I've also been diving into Power Builder development. I work for Ipion, and I've been working here since 2021. First, let's go through an overview of what we're going to be looking at in this session. First, we're going to show how to use the HTTP client to upload and download files. We're going to see what techniques are used to avoid freezing windows when transferring large files. One of these techniques could be to use shared objects to separate the UI logic from the process of downloading, but this is a topic that is more complicated than what we can look at in a single session, so we're not going to be looking at that. We're going to be looking at another approach. We're going to be transferring files hosted both on HTTP file servers. We're going to be providing a sample C# file server for using on this specific aspect. And we're also going to be hosting files on Azure. The reason we're providing a session separate for cloud storage providers is because each type of cloud storage provider might require some special handling because they all have different interfaces. And also they manage the security differently, so it's not going to be the same as what is done for the HTTP file transfer. This entire session is going to be focused around the HTTP client object, which for those of you who are not familiar with it, it is a native PV object that allows sending HTTP requests and receiving HTTP responses from resources identified by an URI. This specific object supports the most commonly used HTTP verbs, which are, among all of them, the head, get, post, put, delete methods. They're the ones we're going to be using for this presentation mainly. And this object also supports up to TLS 1.3, the previous version as well, of course. And supports stream compression for downloading, gzip and broadly, both. For uploading, it's not supported currently, but for downloading, it's automatically uncompressed. First, let's show how to upload files using the HTTP client to a file server. A little bit of context on why this is necessary. Currently, the HTTP client object has a send request method that is used for sending data and the requests to the server. However, this method has an upper limit on how big the payload can be. This is an excerpt from the documentation. It reads, "It is not supported to use this method for processing large data. Large data is considered to be 20 megabytes or 100,000 rows. So if your payload is larger than this method is not recommended." That is why we need to upload the file in parts. This will allow us to update the UI and process the messages that have been sent to the window, making the UI not freeze and confuse the user as to why nothing is happening. For uploading files, large files, the HTTP client provides us with a set of functions. These functions are called postDataStart, postData, and postDataEnd. The names are very self-explanatory, I think, but we're still going to be showing what each function does. For sending a large file with the HTTP client object, first we need to communicate to the server the data size and type. We do this by setting the content length and the content type headers to the HTTP client object with the setRequestHeader function. We then send these headers to the server using the postDataStart method. This will indicate to the server basically how large the file is and the type of the file. We need the server to know how large the data is so that it knows when to stop listening after we have sent all the bytes of the file. The next step is to start sending the data. We do that by using the postData function of the HTTP client object. We send a specific length of data. In this case, we're going to be reading a file in pieces using the fileReadX function. We're going to take that piece and send it with the postData function of the HTTP client object, sending that buffer and the size of that piece. And lastly, we need to indicate to the server that the process has finished using the postDataEnd method. We're going to be using this method when the process finishes or if the user decides to cancel the transfer. With this, we prevent the server from listening indefinitely for the rest of the data that will not come because the user has canceled the process. The mechanisms involved in performing these operations are all part of the HTTP protocol. So the HTTP client is not doing anything magical in the background. This is all implemented inside the HTTP definition itself. To demonstrate how to upload files to an HTTP server using the HTTP client object, we have provided a sample server implemented in C#. The project is going to be attached as a session attachment, so feel free to look into it if you so desire. This HTTP server implemented in C# has a simple authentication scheme. It's hard-coded, so let's take a look to where we configure the credentials. So currently, because this is a sample, they are all hard-coded into the project itself. So this is not meant to be used on production, it's only for demonstration in this session. So these credentials are what we're going to be using to connect to this server, which I'm going to start now. And while that starts, I'm going to run the demo application itself. I'm going to click here on local C# server. And I'm going to use the port that is indicated here to connect to it. So I'm going to use the 5103 and the username and password that are provided on the user store of the project. So I'm going to click here, I'm going to click connect. And this application basically functions as a file browser for a remote server. So we have the files that are currently on the server. If I double click on a folder, we're going to be able to see the contents of that folder. I can go back, I can download the files, I can upload the files. So for this example, since we're demonstrating uploading files to the server, I'm going to right click, upload. I'm going to upload something here. I'm going to go to the desktop. I already have a sample file that I'm going to be uploading. It weighs around 300 megabytes, so it's going to give us plenty of time to showcase some of the functionality of the application itself. I'm going to click open to upload this file. And we can see that we have some UI updates while the process was being performed. So if I do this again, we also have some functionality available to us due to the techniques we are employing for uploading. We can pause the transfer. We can stop the transfer. Of course, this is a normal message that the upload was canceled from the user side. So if I do this again, I can pause, I can resume. And this is thanks to the techniques that we're going to be showcasing in a minute. So if I go to the workspace, the main file in charge of handling the upload of the files is in here, the file transfer helper class in the file transfer helper library. I'm going to take a look at the upload post method to better describe what we're doing. So like I mentioned, first, we have to set the headers of the HTTP client object, indicating the length of the file, the type of the file. The length was extracted from the file that we already selected. Then we start a while loop in which we create a buffer. We read a piece of that file based on a specific chunk size. For this example, we have configured a chunk size of 10 megabytes. So we're going to be transferring 10 megabyte pieces to the server. And for each piece that we read, we send it to the server with the post data function. We pass the buffer, we pass the size of the chunk we read. And then between each piece that we're sending, we're also invoking the callback. This is the callback that will communicate the progress of the transfer. We are passing how many bytes we already read. We're passing the file length so that we can calculate the progress percentage. And we're calling the yield function to allow the window to process any other window messages. If we pause, because I demonstrated we can pause, this is configured through a flag on this object. If this flag is set, we're going to loop over a yield function, practically interrupting the upload and just managing the UI messages. Once this pause flag is unset, we continue the loop. We check if we haven't canceled the process. If it is canceled, it is interrupted. But if it's not interrupted, then we go to the next chunk. Once we have finished the transmission of the file, which is when the reading of the file returns 1, or we have canceled the process, we indicate to the server that we will not be transferring any more data by using the post data end function. And that's pretty much the basic core logic in charge of transferring the files to the server. We have created what we like to call a generic file server browser object that is in charge of connecting and handling the browsing of the HTTP server we created. So this is where we initialize the object, which is past the credentials that we set. And this function checks that the credentials are valid. We also have functionality for browsing the contents of a path inside the server. So this is done by a GET request that the server processes and returns a list of the files. And our functions for downloading and uploading to the server are just passed to the upload post function that we already showed here. So as you can see, the upload process is very straightforward. You only need to perform the steps that we indicated previously, and there's no much more work than that. Now, for downloading from an HTTP server, the context is more or less the same. The HTTP client object has a function called getResponseBody that is meant to be used for retrieving data from the server. However, this method also has an upper limit on how large the data can be, and the constraints are the exact same as when uploading or transferring files to a server. Splitting this transfer into smaller parts has the same benefits as when uploading. So it will allow us to update the UI, offer some feedback to the user, and process messages between each part, preventing the UIs from freezing. The steps for downloading large files are similar. First, we need to prevent the HTTP client object from automatically reading the data, because this is the default setting. So we need to set the auto read data property to false. We can then start receiving the data, so we send the request. Then once we have received the response from the endpoint that we contacted, we read the data piece by piece. In this case, we're taking a specific length of the data into a buffer that we created. After that, after reading the piece, we can write it to a file, or we can collect it on a buffer. To demonstrate the download, I'm going to run the demo again. I'm going to return to the local C# server. I'm going to use the same credentials and same URL that we used previously. I'm going to connect. And this time I'm going to download the file that I uploaded previously. I'm just going to put it under another name. First, I'm going to minimize everything so that you can see what the result is. And back to the window. I'm just going to change the name. I'm going to click Save. We can see it's the same thing. We created another object. We can pause, we can resume. Everything is the exact same process. and everything works as it should. Now let's navigate how this is accomplished. Here on the generic file server browser object, we're going to go to the download object function. We can see that this function calls the download function of our helper class. If we go to the transfer helper class and go back to the download function, we can see and go through the process that it follows to upload the file in pieces. So first we open the file that we're going to be creating. Then we send a request to the server for the file size. We do that using the request file size function. We can take a look at it. All this does is send a head request. The head request will be asking for information on the specified resource that we indicate on the URL. So the specific resource information that we're interested in is the content length of the object. So that's what we're reading from the response. Then we return it to the function for downloading. And here on downloading, after reading the size of the file, we estimate how many chunks we're going to be writing to the disk. This is to calculate the percentage of progress we have made during the download. And as I indicated on the theory, we need to set the auto read data property of the HTTP client object to false. Before doing that, I stored the previous value of that property so that we can restore it later. And then after setting the auto read data property to false, we send the request to the resource URL. We check if everything was successful, and if it was, we then start looping over the creation and transfer of the data to our disk. So we create an empty buffer. We read these many chunks from the response onto this buffer. We update how much data we have read so far, and we immediately write that piece of data to our disk. We update how many chunks we have written, and then we send in an event for updating the UI with the progress of the download. We call yield to allow the runtime to process the message loop. And if we set the pause flag, we loop over the yield, effectively interrupting the download process. If we cancel, we break the loop. And after the loop is finished, meaning that we finished reading all the data, we then check if we didn't cancel, then we trigger the update event one last time to allow the progress bar to reach 100%. And then we restore the previous data of the auto read data property on the HTTP client. We close the object, and if we cancel the transfer, we delete the file we reserved at the beginning. And that's pretty much it. That's essentially the process required for downloading a file from an HTTP server. Now, for uploading to Blob Azure storage, there are a couple of things we need to have ready. First, we need access to an Azure account with Azure Blob Storage. Our account has to have rights to create an SAS token. And we also need to have access to the Blob and Block API. The reason why we need a specific approach for Azure is because uploading files to Azure Blob Storage is performed using specific APIs that require the request verb to be put. And currently, Power Builder doesn't have a mechanism for sending files in pieces through the put method. Fortunately, Azure has APIs for uploading files in parts. These APIs are the put block endpoint and the put block list endpoint. We're going to be making use of these endpoints for uploading of our file in pieces to Azure. And we do that by first uploading the pieces to the put block endpoint. And each piece needs to be identified by a unique name. So we generate a hash from the file path and the chunk number to make sure that is as unique as it can be. And we need to keep track of these hashes because we're going to be using them later for the put block list endpoint. So for the put block endpoint, we pass the chunk, we pass the file that we want to assign that chunk to, and the ID for the chunk. We also have a variable for passing back an error if something bad occurs. And next step is to consolidate all the pieces we sent into a single file. We do that by using the put block list endpoint, passing it the list of unique names we kept. So that's why we were keeping a list of the hashes that we generated. So first, let's take a look at the configuration that we need to have for our Azure container. So we need to have a container ready. I'm going to go to the container. We're going to be first generating the SAS token that we need for accessing the container from our application. For that, we go to the storage account, then go to security, shared access signature, and we need to configure the signature that we're going to be using for querying the files and downloading and uploading. So for that, we need to have access to the blob and file services. So I'm going to unselect the ones that I don't need. We're going to need these 3 types of resources, and I'm going to delete the permissions that I don't need for this example. So I'm just going to unselect them. I'm going to select a sensible expiration date. This should be fine by default. It's only valid for today. And with that, I'm going to click here on generate, and I'm going to copy this SAS token. And then if I go back to our demo application, I'm going to run it. This time I'm going to select Azure Storage, and then the SAS token, I'm going to paste it here. The container URL is obtained from the storage browser. If I go to the storage browser here, I'm going to open the blob containers. The container that I'm going to use for this demo, I'm going to right click, container properties. And this is the URL that I want. I'm going to copy this, go back to the application. I'm going to paste this here and click connect. As we can see, it works the exact same way as it did before. We have our browser, we can navigate to a directory, we can go back. And for this, I'm gonna click here, upload. Here, I'm gonna upload the exact same file that I used for the other example. I'm gonna select it, and it's gonna start transferring. As we can see, since the server is remote and we are splitting our file in 10 megabyte chunks, it's gonna take a little bit longer than if we were doing a single upload. So same thing as before, we can pause, we can resume, we can cancel the process. I'm just gonna speed the process up so that I don't keep you waiting. And as we can see, the transfer finished successfully and our file is right there. Now let's look at how this is accomplished. I'm gonna open the Azure FS class, that is the one that manages the upload and download from Azure. So let's take a look at the upload file function. In here, since we're generating a hash and we're coding that hash as a base 64 string, I'm making use of the coder object and the crypter object to accomplish those tasks. So first, we get the size of the file, and then we open the file. We start reading pieces of the file. The pieces we read are defined by this chunk size variable that we have set in here. We then take that piece, we generate a hash using the file path and chunk number with the SHA-512 algorithm. This will more or less guarantee us that there's not going to be any collision between the chunks, which we don't want, because if we have a collision with the chunks, our file might be assembled incorrectly on Azure and it might be corrupted when we download it. So that's why we're using a relatively secure hashing algorithm using a unique combination of strings. We take that hash, we encode it as base 64. We take a piece of that string to be used as the ID for the block. We don't want the block ID to be too long because that will just encumber our transfer. And then we call the putBlock method, which is very simple. Let's take a look at it. PutBlock method is right here. All it does is make use of our upload put function on our helper class. If we go to our helper class and open the upload put method, we can see that it's very simple. It just sets the header for the content length of the request to the size of the chunk that we're sending and sends the request. There's not a lot much more to it. Now let's return to here. Our URLs for the Azure endpoints are codified in our class. with placeholders for the values that we provide from our URL. So that's why we need to replace these placeholders. And I do that by making use of this replace placeholder function that takes the URL, the placeholder, and the value. After sending this chunk, there's not much else that we do here. So I'm going to return to the upload file function. And right here is where we were. Continuing on, we keep the hash we generated on an array. We increase how many chunks we have read, how many bytes we have read, and we send an update to the UI indicating how much we have uploaded and how large the file is. We then yield to allow processing of the message queue. And for pausing, you already saw this, canceling. And if we didn't interrupt the process, then the call for put block list is done, passing the path of the file that we want to create on Azure and the array of block IDs. Let's take a look at that function. The put block list endpoint takes a XML object indicating all the pieces of the file to consolidate into a single file. Instead of making use of the pbdom classes, because that would be a little bit too cumbersome, I just created a simple string with the IDs of the blocks that we're going to be using. We then set the request headers to the appropriate types. So the content we're sending is an XML. The Azure version we're using is set explicitly to this value because based on my testing, this specific way of structuring the payload is only valid starting from this Azure version. So that's why we're explicitly indicating it here. We then send that request using the put block list URL. And that's it. If we go back to the upload file function, and we were here, then it doesn't do anything else of importance, just closing the file. And that's pretty much how the upload to Azure is handled. This project and the HTTP server implemented on C# are going to be attached to this session for your reference. So in case you have any questions about how something is implemented, or you think you could use some of these objects on your own projects, you are free to do so. The specific object you're looking for is the file transfer helper. This is the one that contains the main logic for uploading files in pieces, mainly this upload post. This upload put is not supported for large files because, like I mentioned, there's no way in Power Builder for uploading large files in pieces through a put request yet. And for downloading, it's this method right here. If you're not interested in the callbacks, you can use the simplified overload for this function. And if you want the functionality of the Azure browser, you can use this object. I just need to mention that this object is a descendant of this other class that encapsulates the interface that is used by both our Azure browser and the generic file browser. So if you need any of those objects, you also need to include this one in your project. So that concludes our demo for this presentation. If you have any more questions or any suggestions for us, feel free to reach us on our community site or on any of our main socials. Thanks for watching. Now begins the Q&A section in which you can ask any questions in the chat, and I will be doing my best to answer them.